be solving problems about combustion analysis. Today our problem is a chemist decides to test what's really inside a mysterious energy cookie that the cafeteria is selling. She takes a 2.500 gram sample of the cookie's special ingredient containing only carbon, hydrogen, and oxygen and burns it completely in a combustion chamber. The products are collected and measured. 3.667 grams of CO2 and 1.500 grams of H2O. Later, she determines the molar mass of the compound is about 180.16 grams per mole. What is the empirical formula of the cookie fuel? So we know this is a combustion analysis problem because it tells us that the mysterious ingredient is only carbon, hydrogen, and oxygen. And when those are the only three elements, that's a clue that it's a combustion analysis problem. And the first thing you want to do in a combustion analysis problem is determine the mass of the carbon, hydrogen, and oxygen. In order to find the mass of the carbon, we take the amount of grams of carbon CO2 there are, which is 3.667 grams. And then we multiply that by the molar mass of carbon over the molar mass of CO2. And when we do that, we get 1.0007 grams. And we don't have to worry about sig figs right now because the more digits we have, the more accurate our number will be. So it's okay if the sig figs aren't totally correct. Now let's do hydrogen. We'll take the amount of H2O we have, which is 1.500 grams, and multiply that times the molar mass of hydrogen. But since there's 2 hydrogens per every 1 oxygen, we want to multiply the molar mass times 2. And we get 0.16815 grams. Now that we have the masses of carbon and hydrogen, we can subtract this from the total mass to find how much oxygen we have. So let's do 2.500 grams minus 1.0007 grams minus 0.168, and we get 1.33115 grams. Alright, now that we have the masses of each of the elements, we want to find how many moles of each of the elements there are, because the empirical formula is basically a ratio of moles. So in order to find moles, we need to divide grams by molar mass. So for carbon, that's 12.01 grams per mole, hydrogen is 1.01 grams per mole, and oxygen is 16.00. And when we do that, we get 0.08332 moles of carbon, 0.16649 moles of hydrogen, and 0.08320 moles of oxygen. So once we're here, what we want to do is divide by the smallest number of moles and divide each of the numbers of moles we have by that smallest number. And this is just because this helps us find the ratio of how much carbon to hydrogen to oxygen this particular compound has. So the smallest number of moles we have here is 0.8320. So if we divide each of these numbers of moles by 0.8320, obviously when we divide 0.8320 by 0.8320, we get 1. And then when we divide 0.08332 by 0.08320, that is basically 1. It's a little bit of a fraction, but we can round up in this case. And when we divide 0.16649 by 0.8320, it's basically 2. All right, so that means that our empirical formula is C, subscript 1, but we don't have to write that. Perfect. All right, for the last step, we have to find the molecular formula. And our empirical formula is CH2O. And the empirical formula is the correct ratio of elements. The molecular formula is the amount of element that is found in this particular compound naturally. So how we can find this ratio is first we have to find what the molar mass of this compound is. So 12.01 grams per mole plus 2 times 1.01 grams per mole plus 16.00 grams per mole. And this equals 30.03 grams per mole. Then we know that the molar mass of the compound is 180.16 grams per mole. So we can do 180.16 grams per mole divided by 30.03 grams per mole. When we do this, we get a number that's pretty close to 6. And this means that naturally the compound, each element is 6 times as much as it is. So it is C6H12O6. And that's the molecular formula.